Hello, everybody. This is Sunday. It's February 26th, and we are headed into Module 8 of our online astronomy course. This is the last of the 4 modules that covers the solar system. And the week after that, that is, a week from tomorrow, your spring break begins. And then after that, we'll have the second exam. So please check your schedules about that. And that means I won't be making a video next week. I'll be making one 2 weeks from today. So, Module 8, the Jovian planets. These are Jupiter, Saturn, Uranus, and Neptune. And unlike the inner terrestrial planets that are closer to the sun, these are all far from the sun. They are very large. They're gaseous. They're not nearly as dense. They're about the same density as water, in fact. And so they differ quite a bit from the interterrestrial planets. And that means that they had a different sort of origin. So what was different about how these planets formed? And you'll find out about that as you go through the material for Module 8. Now, there's also other things that we'll talk about in this module. We'll be talking about asteroids and meteors and comets. Now, we're also talking about those things that are out beyond Neptune's orbit. And these include, by definition, if they're beyond Neptune's orbit, they're called trans-Neptunian objects, TNOs, trans-Neptunian objects. And if those are large enough, we call them dwarf planets. And the dwarf planets include Pluto and Sedna and Eris. And Pluto happened to be the first discovered. And at that time, we didn't know there was anything out there. And at that time, we thought, well, heck, planets are the only thing that orbit the sun. So we included Pluto as a planet, which was just wrong, but we didn't know of anything else to call it. We didn't have examples of anything else. Even though Pluto's orbit was different, all of the planets, from Mercury all the way out to Neptune, orbit the sun in a flat plane, all going around the same direction. Whereas Pluto orbits out of that plane. And so Pluto's orbit was always weird. Pluto's orbit sometimes carries it inside the orbit of Neptune. But usually it's out. In fact, for most of my life, Pluto was inside the orbit of Neptune, but now it's out again and will be out for, over 100 years, well over 100 years. So we call those objects trans-Neptunian objects, and we call the largest of them dwarf planets. And Pluto is around the largest of those. There's some debate about which is actually larger, Pluto or some of the other trans-Neptunian objects. But even Pluto is small compared to the smaller terrestrial planets. I mean, Mars is half the size of Earth. Mercury is a third the size of Earth. But Pluto is several times smaller than even Mercury. So it really is just different. So we'll be learning all about these, how they are different. They have no solid surface. You could not land. You couldn't land on Jupiter, Saturn, Uranus, or Neptune. It don't have solid surfaces. And they all have rings. Although Saturn is the only planet that has a really spectacular, well-developed ring system. But still, Jupiter, Saturn, Uranus, and Neptune do have rings. And this behind me is a really cool picture of Saturn's rings. And it's taken from the side. I'm going to move aside. You can see that a little bit more clearly, that Saturn here, you're looking at, on the left, there is the bright side of Saturn. And so that means the sun is over here where my hand is, and light from the sun is coming in and hitting Saturn. Now, Earth is well inside of Saturn's orbit, much closer to the sun. That means looking from Earth, the only side we ever see of Saturn is the bright side. We might see just a little sliver of the dark side, but usually only the bright side. So this picture of Saturn was taken by a spacecraft that was going past Saturn. It's really a great photo of Saturn. It's one of my favorites. The colors are fairly natural here, and when we look at pictures of Jupiter, you'll see Jupiter's much more colorful, but Saturn's much more muted. And look how thin the rings are. I mean, you can look here and you can see the planet through the rings. And so there's Saturn shining through the rings. So Saturn must be, Saturn's ring system is actually fairly thin. We'll find out it's made of small, icy particles. And that's why it has some of these interesting properties that you'll be finding out about. Now, as I mentioned, there's other things in the solar systems, and those are the asteroids and the meteors and the comets. And the asteroids are mostly located between Mars and Jupiter. Some of them do travel inside. A few of them do travel inside and actually can cause Earth's orbit. And you can believe we're tracking those very carefully. And they are just chunks of rock, big chunks of rock that never came together to form a planet. It's not a planet that broke up somehow. These are chunks of rock that just never formed a planet. And some of the very largest are actually spherical in shape because they have enough gravity to pull themselves into a spherical shape. And the largest of these is named Ceres, C-E-R-E-S, and that is counted as a dwarf planet. And it's the only dwarf planet that is in the inner solar system, inside the asteroid belt. All the rest of them are way out, beyond Neptune. Now, sometimes, the asteroids in the belt are really far spread apart. So any picture you have, oh my gosh, here's one here, and here's one here, and here's one over here, and flying through them must be very dangerous. And no, they are actually far apart. And so crossing through the asteroid belt, you want to be a little bit careful, but you're not in any real danger. You could probably do it with your eyes closed if you had the means to do that. But sometimes they do collide. And we've seen asteroids collide. And when they collide, of course, they crunch together and smaller debris flies off of those. And some of that debris will eventually come in through Earth's atmosphere, just by chance. And those pieces of rock that come in are called meteoroids. And when those meteoroids come into our atmosphere and slam into our atmosphere, they compress the air in front. The air in front of the object is compressed and heated up. And that causes the air and the meteor to glow. And that, in fact, that streak of light is called a meteor. So a meteor is that streak of light. And then if it survives, it may burn up in the atmosphere. Most do, but some are large enough to reach the ground. And when they hit the ground, they are called meteorites. So meteorites is a meteoroid that has plunged through Earth's atmosphere, caused a streak of light, that's the meteor, and has hit the ground, and then it becomes a meteorite. So that's what asteroids and meteors are. And we've actually visited asteroids with spacecraft. We have orbited around asteroids. We have sent rockets, very close to them and studied them. And there's some videos about that to show you what a close-up view of an asteroid is. Now, comets are different. Comets are big, dirty snowballs composed of ice and dust. There are two reservoirs of huge numbers of comets, hundreds of thousands. And the largest of these is way outside the solar system. It's called the Oort clouds. And all of these icy bodies slowly circle the sun. And every once in a while, they might encounter each other or something else gives them a gentle push, and they come inward. And they encounter the planets of the solar system. Now, there's another reservoir of comets called the Kuiper Belt, and it's further closer in to the sun, and it can also send in comets to the solar system. And we've managed to deduce where those comets come from. They weren't originally there; they were kicked out. They were originally, the solar system all formed as one thing, a big pre-solar nebula of gas and dust. But through encounters of the planets, they were kicked out and went into the Kuiper Belt. So pretty cool. And we have sent spacecraft to study comets. They have landed on comets. The European Space Agency sent a lander that rode a comet around the sun and back out again. And as the comet gets close to the sun, its surface warms up. There are jets of gas that are released. The comet's outer surface melts a little bit and releases that gas and dust, and that causes the comet's tail. And actually, there's two tails. There's a dust tail, and there's a gaseous tail from the gases that are released. And they don't always point in the same direction. The dust tail just trails, just goes behind the comet, and then the comet leaves that dust trail behind, and so the dust trail tends to be just back where the comet was moving. But the ion trail, the gaseous trail, that streams directly away from the sun, always pushed by the solar wind and the solar radiation. So you'll be learning all about these things. And you might think, well, these are just minor objects. What do they have to do with us? Well, either a comet or a large asteroid. We're not sure what it was, probably an asteroid. An asteroid hit Earth about 63 million years ago and caused the demise of the dinosaurs. And that means that since the dinosaurs weren't around to act as predators, small little furry mammals could come up and develop and evolve and become us. And so if it weren't for that asteroid that collided with Earth, and it happened in the Yucatan Peninsula, you can see the crater. It actually hit just off the coast, but you can see the crater that's underwater. There's a ring of deep wells all around that crater called cenote that are in the Yucatan Peninsula, and you can visit those, and those are really pretty cool to see. But yep, we are here because of that. If you want to see a closer crater, you can go to Meteor Crater, which is near Winslow, Arizona, and that's about a mile across, and that hit tens of thousands of years ago. There was another, probably a comet that streaked across Russia and exploded in midair around, I think it's 1909. and it's called the Tunguska effect, and it flattened forests for miles and miles around. The sound went around Earth twice from that. And just a couple years ago, there was a huge chunk of rock that came in through the atmosphere and exploded over Russia. I don't know why Russia has a lot of landmass, so that's probably why. That exploded over Russia and shattered windows, and there's some cool videos of that. And in fact, there's just a lot of really interesting stuff, I think, in this module. And so there's quite a few videos here, and I hope you enjoy watching them. Well, it is Sunday, and if you've looked at the news about the weather, you know that there's a snowstorm on the way, but I'm going to show you Stellarium anyway in the hopes that we may get a peek at the sky this week. And so here's Stellarium. There it is. We're looking southwest. This is on Monday night, so this is on the 27th, as you can see over here. And it's about 9 o'clock at night, 2100 hours. Now you see some familiar things, as always. You see here is Orion, constellation of Orion. And here is the red giant Betelgeuse, a white hot giant Rigel, reddish Aldebaran. And Aldebaran is in this area of the sky, which is where the Hyades are. That's one of the star clusters you have to know for your constellation quiz. And over here, a little bit more to the west, is the Pleiades, the constellation of the Pleiades. But I wanted to show you now was a little bit higher up here. The moon is just about at first quarter. And if I zoom in on this, you'll see that it's passing very close to Mars. And it's a cool sight. You can see that through your binoculars, but it'll have to be Monday night because by the next day or a day earlier, the moon will have moved a long way away from Mars. But still, if you happen to be somewhere where you can see the night sky, take a look at the moon passing so close to Mars. Now, there's something else that's happening a little bit later, and I'm just going to zoom out here some more. Let's see here. Right about there. And I'm going to go earlier. So I'm going to go, here we go, closer to sunset. And so this is around 1900 hours, and this is around 7 in the evening. And here's our Jupiter and Venus really close together. And in fact, if you go forward a day, you'll see they're going to pass very close to each other. And in fact, they're going to blend into a single object. So if you see something really bright on the first day of March, and let's see, that is going to be Wednesday. If you happen to look up in the night sky on Wednesday, and the storm is supposed to be passed by then, so we have a chance. And if you take a look through binoculars, you'll see that the two planets are really very close together. And if you have good binoculars or even a telescope, in the same view, you'll see two planets, and that's very unusual. You'll see Venus, and you'll see Jupiter, and you'll see some of its moons. Pretty cool. So there is some good stuff to see in the night sky if the weather will just permit us. So I hope you enjoy learning about the Jovian planets and asteroids and meteoroids and comets and the story of our outer solar system. And I hope you enjoy your spring break too. Have a good time, whatever it is you might be doing. And I will look forward to seeing you when we get back. And when we get back, we're going to start looking at the nearest star, our sun. So until then, bye-bye.